Okay, for part two of the videos on homogeneous differential equations, we'll jump into this problem here. Here we want to find the general solution to this differential equation, which is dy dx is equal to x squared plus y squared all over xy. I'm not going to show you, but if you attempted to make this, separation of variables, so you get the dx's and x's to one side, the dy's and the y's to the other side, you probably can't do it. So we can't use that technique. But we're going to try to put it into the form of homogeneous differential equations here. So you could cross multiply if you like. So I'm going to cross multiply, so I'll get dx times x squared plus y squared. So you see that here. And then I'm going to cross multiply and get xy dy. All right. Now, I'm going to move the xy dy term over to the left side because I'm trying to put it into this form here. M of xy function dx plus the n of xy function dy equals 0. So if I do, I want to check, and I'm not going to show you here, but if you go ahead and look at this and replace the x with tx and the y with ty, like we did in earlier parts of this, you would find this is homogeneous of degree 2. And likewise, if you take the xy function here and do the same thing, you'll find it's homogeneous of degree 2. So since they both match in degree 2, this is a homogeneous differential equation of degree 2, which means we can use this fancy replace y's with kind of v stuff and dy's with dv's and dx's, as you'll see here in a second. And then we can separate the variables. Doesn't mean it's always easy, but that's what we can do. So we're going to transform this into differential equations whose variables are separated by using these two substitutions. We're going to replace y with vx, where v is a function of x, and the second part I'm going to show you here. So let's take y equals vx and take the derivative of both sides. So I'm going to take the derivative of y with respect to x, and I'm going to take the derivative with respect to x on the right side. So I would get first, it's product rule. First times the derivative of x, well, v times the derivative of x with respect to x is just 1, so I get v, plus the second, which is x, times the derivative of the first, well, the derivative of v with respect to x. Now, if you take a look at this derivative equation here, I'm going to multiply both sides by dx. So on the left side, that'll just leave me dy equals, and then on the right side, I'll get v dx plus x dv, because the dx multiplication on this second term would cancel the dx there. So these two boxes form the substitutions we're going to use here. So I'm going to replace all the y's in this differential equation up here with vx, and I'm going to replace all the dx's with v dx plus x dv. All right, that's all I'm going to do. So I go up here, there's an x squared, so I just write it down. Plus, there's y squared. Well, the y gets replaced with vx, so it's vx squared. There's the dx, it matches up. Minus, there's the minus sign. X, there's the x down here. There's y, I'm going to replace it with vx, so I get x times vx. Now I've got this dy, so what are we going to replace dy with? Dy gets replaced with v dx plus x dv. So that's all right here. Equals 0, 0. All right? Now, the rest of this is just trying to get all the x's with dx and all the v's with dv. So first thing I'm going to do is just take vx and square it, and I get v squared x squared. Over here, I'm going to distribute the negative x vx through the parentheses, and that'll give me negative v squared x squared dx minus vx cubed dv equals 3. Then I'm going to distribute this dx through these parentheses, and I'll get x squared dx plus v squared x squared dx and then these two terms that were already kind of simplified. Sometimes what you'll be able to do is combine some like terms, and I do have two like terms here that are exactly the same, except one is negative and one's positive. So they cancel, leaving me just with x squared dx minus v x cubed dv equals 0. All right, so I'm going to move the dv term to the other side because I'm going to try to separate x's and dx's from v's and dv's. So I'm just added this to both sides. Now on the right side I have v and dv. I just want to get rid of this x cubed, so I'm going to divide both sides by x cubed. Well, I already have an x squared on the left side, so x squared divided by x cubed leaves me with 1 over x. So I have 1 over x dx equals v dv. It is separated out now in terms of x's and dx and v's and dv's. So I'm going to integrate both sides with respect to whatever. On the left side with respect to x, right side with respect to v. The integral of 1 over x is the natural log of the absolute value of x, and the integral of v dx is v squared over 2, or 1/2 v squared, and I'm going to put a plus c on the right side. All right? So that's what we have here. So now, after I'm done with the integration, my original problem did not have v's, so I'm going to substitute out of the v's and back into the y's, actually the y's and the x's. Because if I solve this for v, v is y over x. So I have v is equal to y over x. So I'm going to replace this v here, which is being squared, with y over x. So it's going to be y over x, the whole thing squared, or y squared over x squared. Now, the next part is not always easy. This one isn't too bad. I want to solve for y if I'm able to, all right, to get my solution. And I don't know why this came out to be so blurry down here, but that's my bad. We'll make it work. All right, so what I'm going to do is just change this first term on the right side into y squared over 2x squared. And then I'm going to solve for y squared over 2x squared first. So I'll subtract c from both sides, and then I flipped it. All right. Now I'm going to multiply both sides by 2x squared, so I'll get y squared is equal to 2x squared times parenthesis natural log absolute value of x minus c. All right, so almost have it. I just need to take the square root now. So I take the square root of both sides, but it was y was being squared, so when I take the square root, y will be plus or minus the square root of everything that I see on the right side here. Okay? Now, the only thing that's easy to sort of pull out from underneath the square root is this x squared right here. So I pull square root of x squared, because this is all multiplication. 2 times x squared times this parenthesis. All right? So I can pull an x out. So y is equal to plus or minus x times the square root of 2 times, in parentheses, natural log of absolute value of x minus c. So this is the solution to the differential equation that we're given. I didn't have any initial conditions to go any further with that, to find out what c would be and to figure out whether we wanted the plus or minus version. But that gives you a flavor of how to do these problems here. And trying to solve for y is not always easy. There's a lot of algebra involved. All right? So hopefully that gives you an idea what this new topic of homogeneous differential equations is all about.